ESS revision video for food production, and today we're looking at terrestrial food production and its impact on the. So for this module you need to be familiar with some key terminology. So the first term is LEDC, which is less economically developed country, and MEDC, more economically developed country. We'll also be talking about agribusiness, which is the business of agriculture, so from seeds production to machinery to fertilizer production, all those things considered as agribusiness. We'll look at commercial agriculture, which is large-scale production of crops and livestock to be sold. And we'll look at subsistence farming, which is when you farm for enough for your family only. You need to be familiar with, because I'll often ask you a question to compare the sustainability of one type to another, are as follows. So arable farming is when we're sowing crops for food, resources or fuel, whereas pastoral farming is when we're raising animals normally on the land that is not suitable to crops. Nomadic pastoralism is when people move across land, often common land, with animals to find water and food. Extensive farming is when there's low levels of input, so we don't use much fertilizer or pesticides, machinery or labor, and you get lower output. But intensive farming, or sometimes called factory farming, is where you have high levels of input, so you might put in lots of energy, fertilizers, pesticides, use lots of machinery, but you get high levels of output as a result. And just because you get high levels of output, though, doesn't mean it's as efficient, because you've obviously put so much into it. Irrigated means the idea of directing stored water to supply crops, which is 70% of our global water use is in irrigation of crops. Hydroponics is the science of growing plants without soil by giving them dissolved minerals in water. We can do this indoors. There's less competition, there's less watering, because we can use more efficient systems as a result. And many think that's the future to feed the populations. Organic farming is avoiding synthetic chemicals and utilises techniques such as crop rotation, green manures and compost to maintain fertile soil, and biological controls are used to reduce pests and disease. So for example, you might add ladybirds which kill insects. And inorganic farming is the use of synthetic fertilizers and pesticides, and it's often linked with. So we need to think about what different things are more sustainable and unsustainable. So obviously it's very easy just to suggest that commercial farming is going to be less sustainable than subsistence farming. But if we actually look at it, we need to compare the two different things. So on an agribusiness basis, commercial farming is basically going to have lots of practices, and therefore you can actually function with environmental sound practices, whereas subsistence for farming tends to be much more based around just doing it for yourself, and therefore probably have less impact. The scale of the farming, obviously commercial farming is going to be large scale, will often rely on machinery, chemicals, extensive use of fertilizers, and therefore it's going to have a lot more impact. However, don't be led to think that the impact, there is still chemicals being used often in subsistence farming, and it can still have clearing of trees and able to happen, so it can still have an impact on the environment. Industrialization then, people often work in farms, large-scale commercial farms, and obviously, but in terms, so it's much more industrialised, it's much more efficient, it's using much more machinery. Obviously, this is much more limited on subsistence farming. Mechanisation, as I said then, lots of heavy machinery is used on commercial farming, using lots of fossil fuels, which have a negative impact. Often animals are used, they're called draft animals, to help subsistence farming. They're powered, and basically you'll add manure to the farms to help them grow. Fossil fuel usage, as we just said, commercial farming is going to use a high dependence on fossil fuels from fuel for the farm, whereas manual labour and draft animals don't use those on subsistence farming. seed, crop, livestock choices, commercial farming, will keep animals that are sometimes not indigenous to the area, and ones that will create a need for in irrigation, greenhouses and extra stuff, whereas generally there'll be less of an issue here with subsistence farming that will use local crops. Water use. Obviously, water use in some areas of agriculture is extremely heavy, and that means they have to use local water supplies, which can cause problems of lack of water. But obviously, subsistence farming can use water, and if a large number of people are doing it, it can still be unsustainable. Fertilizers and pest control. High amounts of fertilizer, high amounts of pesticides are used in commercial farming. Subsistence farming is more likely to do rotation of crops, but they may still use some chemicals as well. Antibiotics are used in commercial farming, particularly with livestock breeding. They tend to happen less and doesn't tend to happen in subsistence farming where animals are free and more spread out. And legislation is large scale to control the interests and cause pollution. Less is happening in commercial farming, less impact on subsistence farming, so any damage that does occur often isn't monitored. And pollinators, the pollinators are really important in commercial farming. So the collapse of like the honeybee has massive impacts on almond farming in California, but often they have less pollinators actually on the farm because of the monoculture. But in subsistence farming, there's less of an issue with this because a different variety of crops grown will attract different insects. So we need to understand them about the term malnutrition, and malnutrition effectively means an unbalanced diet. Now, if you say it means a lack of food, you are incorrect because there are different levels of malnutrition. So the first level of malnutrition is being undernourished, which is what most people associate it with being a lack of calories. You can also be overnourished, which leads to obesity, which means too many calories. And unbalanced means you get the wrong proportion of the food groups or the micronutrients. And every country in the world is actually affected in some way by malnutrition. Some people get too much calories, some people get too little calories, and some people get the wrong portions. And basically there are three phases of malnutrition. It can cause stunting of growth, so that can obviously be a big problem. It can, in children, it can cause a lack of weight and wasting, i.e. the children are too thin for their height, and it can cause overweight in particular areas of the world as well. Now, why does this happen? Well, more economically developed countries often have overnutrition and overweight because there is relatively cheap food prices. That means purchasing often has occurred due to choice rather than nutritional need, and there is less seasonal variation, I should say, not variety, apologies, due to importing food. So you can get the same food all year round. So this then leads us to obviously bad education, bad choices, which can lead to either a lack of certain food groups or too much and therefore leading to obesity. Less economically developed countries have often higher food prices relative to wages, and this means purchasing needs to be based more on needs. And also political pressures can mean that food is often exported, which is called cash cropping, rather than given to the population, often leading to not enough food or not enough calories for people. So factors that can affect what food choice is grown can be climate, and we don't mean climate change necessarily by that, we mean the climate. So in the UK we can grow certain crops. In different parts of the UK we haven't been able to grow much grapes for wine until more recently because of climate change, but we have specific climates. If you go to the Mediterranean, you can grow olives due to the higher temperatures all year round. Culture and religious reasons might stop things being grown. So for example, people who religions that might not like pork, so therefore pigs may not be grown. Political reasons can happen, so some governments will give subsidies to grow certain crops, some might put tariffs on to grow other crops to direct the farmers to grow certain things. And there might be socio-economic reasons, so food prices will rise and fall with demand, and that can affect what farmers choose to grow. With food production, then, we should have enough food for every person on Earth, and they estimate that we currently could feed everyone with that many calories, where 2,000 is the average calorie needed for a man. However, that isn't the case. There are over 1 billion people in food poverty, and that isn't because of a lack of ability. We can actually grow 23% more food now due to technology than we could 50, 60 years ago. However, it's that lack of distribution around the world and even. So one area is livestock farming, and we need to know, well, why do we grow livestock? Where did this happen? Well, this actually happened, animal domestication happened before we actually started even growing crops. And this is because we started using dogs as hunting companions and then help with herding of sheep. Sheep and goats were first hunted in the wild, and then we realised we could keep them domesticated in farms. Cattle, reindeer, horses were originally kept for food, but then started to become animals of burden, so they helped us do jobs, for example. And we realised we could use the wool, the hides, and the bones of animals to keep warm or use for tools. Livestock is also a useful way of developing and converting unsuitable plant material to valuable protein as a result of the animals eating it. So, for example, we can't eat grass, but the cows can eat grass, and then we can eat the cow meat. Growing crops is called arable farming, and growing crops. So arable farming then is when we deliberately sow seeds into the soil, clear natural vegetation, and then plant one crop, which, as you are probably aware, is called a monoculture. Fertilizers can then be added, which obviously increases the growth rate. And harvesting can happen, which is the removal of biomass from the soil, and over time that reduces the soil fertility because the plants aren't decomposing, and then therefore they're not returning the soil nutrients back into the soil. So that's one of the reasons we have to use the fertilizers. Crop rotation can be used to increase soil. So you need to be able to treat farming as if it is a system, so a closed or an open system where materials can be exchanged, stored, and moved in and out of the system. So for example, if we're looking at cereal growing is obviously very commercial. It uses high levels of inputs such as technology and fertilizers. The outputs are relatively low per hectare, but high per farmer, because farmers will have high amounts of land. It's got enough medium efficiency, and the impact can be high because we use lots of land, so therefore we're losing lots of ecosystems. There's lots of soil erosion and potential loss of biodiversity. We look at a different one. If we look at dairying or horticulture, they've got high amounts of outputs, high amounts of inputs, and the efficiency is high, but there is impact because there's lots of greenhouses, and dairies, there's lots of waste from the cows. So you need to be able to look at a farming system and identify, is it a high impact, high outputs, and what is the impact on the environment. So this links to something called the farmer's energy budget, and this can be measured in one of two ways. You can look at the amount of energy that are returned from different crops, but this is difficult because you don't always eat the whole crop. And in livestock, a lot of the animal actually doesn't get consumed, or is a lot of its water, so you have to think about how much is actually energy coming out to the consumer. You can also measure the overall efficiency by measuring the inputs and outputs, as I just mentioned, but most of them unfortunately have a lower. So that means we input more energy than we actually get out, and that's other than cereal. But even in this case, you need to look at the quality of energy, because you need to eat a lot more cereal to get the same amount of energy that you would to eat a piece of beef, for example. You need to be able to compare farming systems. So here is an example of rice production, which is done in Borneo in a more traditional way. And you can see in Borneo that there is, in terms of inputs, quite low, quite high, so we'll get there eventually. In terms of labour, there's quite high levels of input, but everything else there is very low because there's no machineries used, no petrol or gas used. So the energy and chemical input's quite low, high labour costs, but at the end you eventually get quite a low output in comparison. But because of this low input and low output, overall it's very efficient as a system. In California, where they're using intensive farming, use high amounts of energy input, all these energy uses here, very little human labour, however, but you get high output as a result. Now that, however, doesn't mean it's efficient because of the comparison between input and output. And also you have to consider in California the fact that this commercial use of fertilizers and diesel and petrol is leading to more pollution, making it less sustainable overall. And this can be looked at, and you need to think about different methods in traditional farming and intensive farming and how they compare. So intensive farming, or extensive farming we should call it, is going to use limited selective breeding, whereas intensive farming systems are going to have much higher selective breeding rates. They don't tend to use genetically modified traditional systems, but they will do more and more in intensive farming. Polyculture, there might be lots of different crops in normal and traditional farming, but monoculture in more intensive farming, and therefore there's a low effect of biodiversity there, but a high there. And soil erosion is a big problem with intensive farming. To compare, where do we get our food? So if we get our food from terrestrial systems, because we're on the land, I guess the sunlight is readily available, but we tend to eat the first or second trophic level of the food chain. We either eat the crops or we eat the animal that eats the crops. This means we get an efficient amount of solar energy transfers and losses, but there are losses we need to take into account in terms of the fact we don't eat things like skeletons that are not passed on to humans. If we compare that to aquatic ecosystems, we often eat carnivorous fish, which might be trophic level 4 in the food chain. So by this point, lots of energy has been lost through the food chain, and therefore there is a low efficiency. Also, as it's in water, more energy has to be made into heat to keep the fish warm, so there's more energy lost as heat and not turned into biomass and growth. If we want to increase food production, though, this is a question you could be asked, how can we do it? Well, one thing is we could try. So we need to be able to increase the yield. So we can do this in lots of different ways, but the problem with increasing the yield is mainly it's going to involve chemicals, and we need to try and do it sustainably. So what other things can we do? Well, we can improve technology, which we can do by using different technological approaches, such as we can mix cropping to conserve water, to do different crops in different fields in the same field. We can use buffer zones around the outside to have areas where there's no crops being grown around the outside of fields to avoid runoff, so water is caught by trees, for example. We can use biological controls rather than pesticides, and we can use trickle irrigation rather than spraying, which is also mentioned several other times in this module. We can alter the crops that we grow. So we can use genetically modified crops, which might be resistant to drought or might grow quicker or might be resistant to disease. So therefore we don't need to spray as much. We can use legumes, which are crops like beans and peas, which have bacteria in them called rhizobium, and that allows them to absorb nitrogen from the atmosphere, meaning they replenish the nitrogen in the soil. We can use hydroponics, which is growing, you can even grow indoors where you just provide water and the right nutrients, and therefore less soil is needed as a result. And we can require agriculture, so we can use aquaculture, for fisheries rather than catching wild fish, but there's often problems with this. Look back at the water module to have topic 4 to have a look at why. There is a green revolution which can be developed again, so we can use agroecology, which is the idea of making the farm a closed system. So we're effectively trying to make the system maintain itself by using a clever mix of animals and plants, so you have to put less fertilizers in on the plant. Crops again that are resistant to drought, which means it's less fertilizers and less water being needed in this case, and you can look at different methods to actually preserve the soil. Reducing food waste is probably a key thing. This is done in different ways. So in less economically developed countries, this can include production problems and storage problems. So in very poor countries, they might have refrigerators, so the food doesn't last as long, so it gets wasted due to this. In more economically developed countries, consumption might be a problem. And consumption is that we either eat too much, we have too big plates, we don't finish the food, we buy too much and we don't actually use it before the sell-by date, or there is sell-by dates when there shouldn't be. Monitoring and control, so governments can monitor and control food consumption and monitor what comes into the country and monitor what is grown. We can try and change attitudes towards food and diet, so trying to make people eat new crops, make people eat less meat. And one theory is that we should be looking at eating insects, which are very high in protein earlier on in the food chain, so they have more energy in them per gram. We can increase education so people waste less food and think about lower carbon impact foods, and we can reduce food processing and labelling to make it more sustainable. So this comes from quite an old book where the specification is now maybe slightly out of date, but future predictions for 2030 and food production are the human population will have been above 8 billion. Well, that happened on the 15th of November 2022, Mr. Phillips' 40th birthday, and so we know that there it could even reach be high up in that level by then. Calorie consumption will have gone up to about 3,000 calories per day in areas where people have lots of food, so in maybe more economically developed countries. Hungry people, the numbers of hungry people around the world will fall, but that won't be equally, it'll happen in different places at different times. More people will eat more meat, which you can see by the cattle increase around the world. Extra billion tons of cereal will be needed to help feed the world. And increased yield will come from technology and better irrigation, but not from using more land. Genetically modified crops will increase food production by improving pest control and allowing crops to survive harsher climate change conditions. Aquaculture will also have to increase.